Okay, so today we're going to find A, the intervals of which f is increasing, B, the intervals in which f is decreasing, and C, on which the interval is concave up, and D, the open interval when concave down, and the x coordinates and the x inflection point. So we are given f of x equals x squared minus 3x plus 8. So we got to find the increasing and decreasing. So all you got to do is take the first derivative. So take the first derivative of f of x. So f prime of x is 2x minus 3. Next step is set that 2x minus 3 to 0, and this will give you, and then solve for x, which will give you your critical points. So 2x minus 3 equals 0, and then solve for x, so you add 3 on both sides. So 2x equals 3/2, which is about 1.5. So now you gotta test points to see if it's increasing. So put it in a number plot. So put 3/2 in the middle, because that's our only critical point. And then to figure out if it's increasing, you need a number that's bigger than 3/2 and a number that's less than 3/2. So I'm going to use positive 3, and I'm going to put it in the first prime, not the original one. So f prime 3 is you just plug in 3 into the f prime of x, so it's 2 times 3, which is 6, minus 3, which is 3, which is positive, so that's all we need to know if it's positive. So you could, on the right here, you just put positive sign. And then now we need to go the left side of 3/2, so we're going to use a number that's less than 3/2. I'm just going to use 0 because it's simple and it's less than 3/2. So f of 0 is minus 3, which is negative 3, which all we need to know is negative numbers, so we're just going to put a negative on the left side. So our increasing is from this interval, wherever you see a positive, and decreasing is whenever you see a negative. So increasing is from 3/2 to positive infinity. It should be instead of parentheses, it should be bracket 3/2. And decreasing is from negative infinity to positive infinity. I mean, negative infinity to positive 3/2 brackets, not parentheses. And we have a local min. So whenever you have a local min, you just look at this chart. So when we have a negative and a positive, that means it's a local min. If you had a positive and a negative, then you have a local max. And then to find since you only know the local min at x value, to find the y value, you plug it back to the original equation. So you plug it back into plug it back into x squared minus 3x plus 8. So when you do all the math, you should get 23/4, which is about 5.7. So the coordinate for our local min is at x equals 3/2 and y is 5.75. So now we gotta find the inflection points, and then we gotta find concave up and concave down. So to find the inflection points, you take the second derivative. So the second derivative of 2x minus 3 is just 2. So since we don't have an x value, we don't have an inflection point. So there's no inflection point for this one. And then I'll show you when I graph it. Okay, I won't tell. I will show you. Okay, so for concavity up and down, I'll show you why there isn't a concave. So if you were to graph this, right, you get x squared. You know this is a polynomial, and it's going to look something like this, right? Right, because it's an even degree. So it's going to make like a parabola. So you can find the y-intercept by plugging 0 into the original function, right? Let me just graph these. So to find the y-intercept, you plug in 0 into the original function of f of x of 0. So your y-intercept is just 0, 8. Okay, and now we just look at our local min, right? So our local min is at 1.5 and 5.75. Oops. So here's our local min, right? Here's our y-intercept, and we know it's a parabola or a u-shaped polynomial, right? Because it's even degree. So that's why we do not have sorry, our concave up is this, right? Our concave up. So our intervals from concave up is from negative infinity to positive infinity. We do not have a concave down because a concave down would be like it'd be like a U shape, but like the opposite. It would have to be like a negative x squared, so we don't have a concave down. And the reason why we don't have an inflection point, so an inflection point should be right in between a concave up and a concave down. We don't have a concave down, so there's no inflection point. So that's pretty much it. Just so let me quickly review it. So define the intervals for increasing and decreasing. You take the first derivative, and then you set that, whatever you get, you set that to 0. And then you solve for x. That x will give you your critical point. And then you do the number line, so you got to figure out which one is positive and which is negative on the right and left side. So you just plug in points. So I used positive 3, right? And that tells me on the right side it's positive. And on the left side I use 0 because it's less than 3/2, and you get a negative. So that's how we get a negative. So that's how you know you're increasing, decreasing. In our local min, whenever you have a negative and a positive, that's a local min. If it was a positive and a negative, it's a local max. And then define the concavity up and down and inflection point. You just have to take the second derivative, but we notice that we don't have an inflection points because we don't have a concave. We don't both have a concave up and a concave down. So that's it.